So, having read the information up in the text box, would this be an observational study or an experiment? Experiment, why? Random assignment. What are they randomly assigning? Yeah, the rows, the seats. So it's an experiment because a treatment is being imposed. We have random assignment being imposed on row assignment. Why is it important to randomly assign the students to seats rather than letting each student choose his or her own seat? I'm sorry, one more time? True. Yes.
There's no random assignment, you can't throw causation.
Yes. Your statement was not false, but specifically when we're looking at an assignment, experiment, we want our random assignment so that we can show causation. This would allow us to say that being seated closer to the front increases your score or decreases your score, etc. I want you guys to take this information. We're going to input it into your calculator. And we're going to make a scatter plot. First of all, how many variables are we looking at here? 2 variables. What are those variables? Row and score. Are they categorical or quantitative? They're quantitative. The row has a number assigned to it, and then their scores are obviously quantitative scores. Which one would be our x? Row. And so our y variable would be score. Does anybody remember how to do a scatter plot on their calculators? Go ahead and pull those out for me. We're going to kind of walk through it together. So first thing you want to do is make sure that your stat plot is turned on and that it's turned on to a scatter plot. So I'm going to hit second and y equals. Mine says it is currently turned off. Whether yours is on or off, you need to enter this first one. If off is highlighted, you need to hit enter so that now it is flashing on the on. Then it's darkened around there. And then you want to choose this first type of graph, that is our scatter plot. If it does not already have a scatter plot lit up for you, you want to hover over that and then hit enter. So far, so good? All right, we got your scatter plot turned on. We're going to go enter our data now. So go to Stat and Edit. You're going to enter your x variables into list 1 and your y variables into list 2, which means you need to enter row 1 how many times? 6 times. Each row has 6 students, so you're going to enter each of these 6 times. Once you have all 30 of the row assignments entered, you want to arrow over to list 2 and enter each student's score. sure that your very last entry, you actually hit enter so that it enters it on the table. And double check that your X list and your Y list have the same number of values in them. So they should all be forming ordered pairs, matched pairs. Does everybody see that much? Okay. I want to look at this. The best way to make sure that my calculator is automatically going to size the window so that I can see all of this data, I'm going to hit zoom right here. Option number 9 should say zoom stat. And then you should see your scatter plot on the screen. Does anybody not see a scatter plot? Go ahead and sketch that down underneath number 4. We did answer the questions in number 3, but I'll put that up here on the screen in a minute. Sketch the scatter plot. In addition to just sketching the scatter plot, make sure you label the X and Y axis. What were our X values representing again? Row. So down here you want row, and you could even go ahead and label those since we only had 5 rows, 1 through 5. And then the Y axis should be labeled what? Score. And if you use trace, you can get an idea for scale. So I know that this dot right here is 77. I can use that to kind of draw a scale on my y-axis here. If you use the right arrow, it will move through those points so that you can see your y values to try to get a scale on your y-axis drawn. When we were doing scatter plots first semester, scatter plot's great, it lets me see my data. Does anybody remember what we usually wanted to do once we had a scatter plot with 2 pieces of quantitative data? What did you say? We did use those to describe it. There was something that we did with our scatter plot first. Least squares regression line. We can have our calculators calculate our least squares regression line for us. To calculate your least squares regression line, you're going to go to Stat. You're going to arrow over to Calc. We want option number 8. It says linear regression, A plus BX. I know they have normal looking slope-intercept form here for option 4. Statistics form gives us our y-intercept first plus slope times our x. So we want option number 8. So I'm going to hit 8. It's going to ask me where my data is coming from. Make sure that your X list is list 1, your Y list is list 2. As long as that is correct, you can go down to calculate. hit enter, and it will give you the values for A and for B. We're going to round this off to 2, 3 decimal places. I must have entered one piece of data wrong. I got 85.95 for my y-intercept the first time I did it, so I'm guessing I entered one piece of data incorrectly. I apologize. So 85.95 for your A value, and your slope, negative 1.517 when we go out to 3 decimal places. I'll have to go back and look at what piece of data I entered incorrectly. You can have your graphing calculator graph this linear regression line on your scatter plot, and we're going to add that to your picture here. So to make it graph it, you're going to go to y equals right here. After you're in y equals, and it's flashing on y1, there shouldn't be any other values for any other of the y equals. We're going to hit vars, not second vars, just vars. Option 5 says statistics. I'm going to arrow over to EQ for equation, and I want it to enter that regression equation it just found. So I'm going to choose option number 1. And it will copy and paste it in its exact form into that y equals. Now if I hit graph, it's going to put my regression line right there. If anybody needs me to walk through those steps again, I'm more than happy to do that. But we want to add your regression line to that picture. On the screen, I've got it just a little bit differently here. So again, statistics form for a regression equation has the y-intercept first, and then our slope second. Excuse me. When we go to write our equation, this regression equation, is it going to give us a student's precise score? What's it giving us? What is this regression equation showing us? I have the least squares, so I've calculated the least squares here and the least squares here, and that's how we got our y-intercept and our slope. This regression line is going to allow me to make predictions about student scores. The actual student scores are represented by the different dots in my scatter plot. But this regression line is going to allow me to predict a student's score. The way we indicate that we are making a prediction is we have y hat. And when we write out our equation, we usually don't write y hat equals and then our numbers and then x. We're going to put our variables into our equation when we write it so that we know exactly what we're predicting and we know exactly what our input information is. So there's our equation. Find the least squares regression line. So I'm going to start this off with score hat equals. Score hat equals. This is what we're predicting. That's what that hat means. We're not calculating a student's score, we're calculating a prediction for the student's score. What was our y-intercept again? 85.95. And our slope? negative 1.517, and then we need our x variable. What was our x variable? Rho. So inside parentheses, I'm going to have rho. Why doesn't rho have a hat over it? We're not predicting the rho. We're saying if I know a student's rho, I'm going to use that to predict their score. So score has a hat over it, but rho does not. If you want to write this as a y equals equation, y hat equals blah, 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 x, you have to explain what y hat means. You have to explain what x means. So somewhere up above, you would have to have y hat equals predicted student score. X equals student's rho. It's usually easier just to write it out in the equation, and this is the standard way that you'll see it written out statistically. What was our slope again? Negative 1.517. What would that mean in the context of our problem here?
As a student moves further back in the classroom, the predicted score decreases by 1.517.
Yes, 1.517 what? Points, yes. So for each additional row, or for each row a student moves back, you want to have some for each or for every. The idea is for every increase of 1 in our x variable. So for every additional row, a student's predicted score, it's really important that you say it is their predicted score, goes down by 1.517 points. You would not put a negative when you're describing the meaning. You're going to explain that it's either going up or going down, and then you want to include context here. It's been a minute since we've done this. Does this negative slope provide convincing evidence that sitting in a lower row, like row 2, row 3, row 4, or sorry, a lower row, row 1, row 2, causes a higher exam score, and a higher row causes a lower exam score? Do we have convincing evidence just from a negative slope? Is it plausible that this association is purely by chance? So we have some evidence. I don't know that it's convincing evidence. How would we determine whether or not it was convincing evidence? In order to answer that question, we need to know more about purely by chance because of the random assignment part, which is exactly what you guys were bringing up. If we assume that the seat location has no effect on the exam score, so that would be our null hypothesis. Seat location has no effect on the exam score. Then we could just randomly assign all 30 exam scores to each of the seat locations. We are going to do this. I have cards with all of the exam scores written down. My 6-year-old did help me make these cards, so if you can't read a number, please raise your hand and ask. I can interpret 6-year-old pretty well. So I want you guys to shuffle up the cards. You're going to put 6 scores in each of the 5 rows in front of you. And then you'll copy that down onto your page. You're going to find the least squares regression line and record the slope. And you're going to end up doing this a total of 3 times. That saves you the trouble of having to type it in by hand and use it precisely. make sure that you shuffle up the cards ahead of time, lay them out in 5 rows. Again, if there's any numbers that you can't read, I am happy to help decipher 6-year-old. Did anybody not get, oh. Repeat the process for calculating the least squares regression line, and we are interested in the b value, the slope for each of these. Go ahead and do it too. So when you go to calculate the slopes, you can leave your X list alone and you'll just be entering a new Y list, a new list 2. You have your 3 slopes. You can come and add 3 dots up here. That will give us our dot plot. On your desk, you're going to mix them up. You're going to randomly assign them to 5 rows, and then you're going to calculate the least squares regression line of that new assignment, and you want to record the slope. So that'll go for the first one. You'll have your assignment find the slope of the least squares regression line. You're going to do that a total of 3 times. Once you have those 3 slopes calculated, you'll come and put a dot up here on the dot plot for each of those slopes. Try to finish up your calculations. We'll have to do our analysis portion of this tomorrow. Finish up your calculations and get your dots up here. Those of you that have the opportunity, go ahead and record our dot plot in your notes. I'll make sure that this is the first thing that gets put up on the board tomorrow. Has everybody gotten their dots up on the board?
No.
No, okay.
What we did at let's go to news, we did this complicated initial walker. It was amazing. So we did so bad initial walker. And so both teams are out this season. Vex is out. First, they're out.
If you still need to record dots up on the board, this will be up first thing tomorrow when you come in, so you can record your dots. And then we will analyze what this is telling you. Have a great rest of your day, guys. I'll see you tomorrow.